Okay, welcome to Nested Loops. We're going to jump back to chapter 20, and that's what we'll cover today. Apologize for that. So I'm picking that up, and I will share my screen here once I figure out the different than the other Hangouts menu. All right, so part 7 is factories. We started out last week. We actually jumped ahead into singleton, double check blocking. We were supposed to introduce factories before that, and they did make some reference to factories in singleton, primarily that you make the singleton from the factory. So it would have been good to have done that earlier. And actually, Meetup says there are 3 guys want to join, so if they're on the YouTube, if you go back to Meetup, in the comments, I've added the Hangout URL so that you can participate along and speak to us. So, all right. So we're going to discuss use of factories. They are objects that make other objects. Though they're presented there, they're not. Use is not discussed fully. Okay. But they are mentioned, but they don't clearly come straight out into factory. They have abstract factory and factory method are the ones that are actually in the Game of 4 book, and they don't come right and say what a factory is. So the things we're going to cover is why factories simplify our design and code, which is the valuable part, and then the proper steps of seeing what the objects are first, and then deciding how to create the manager. So this line here is really the theme that he beats down a couple of times, that this is how you should do it. So again, on what factories are, factories encapsulate business rules for creating objects. And as a designer, he is considered with the behavior of the objects, what they do and how others interact with them. But related, you also have to figure out when an object is needed and making sure it's ready. So those details here. So normally, and this is a lot of things about, I want to say good, but maybe the more correct adjective is well-developed or current object-oriented methodology is a lot of the things are not as intuitive as before. So right here, he's making this comment, we often lump the management of object creation with object instantiation. And then he jumps back and says, well, when you do procedural languages, you know, you're kind of writing all your code at one time. Oh, here's my situation. So I write some code that does some stuff and I make the objects. So in procedures, I do this, and that's useful for a short task because everything is in one place. But as the code gets longer or bigger, it gets harder to manage. You don't get to reuse stuff. You end up cutting and pasting, and that's very common for procedural languages. And then he goes on to say what I just said. They're thinking about implementation levels. But what object-oriented programming languages, not just the language, but actually the correct approach, is a new problem and a new opportunity. So he talks about this stuff, but in general, and he says, you know, reduces cohesion. The problem with doing all that in one place, you have code that does both the object use as well as creation. And so it's, I say back here, it's not SRP, not single responsibility principle. And I will beat that down in the other parts here. And one mistake you can do when you're putting everything together like that is that you choose instantiation scheme too early. And primarily because before you know it needs to be instantiated. So he says here, I much prefer not getting locked into an approach until I know the most appropriate approach to use. And so this is a big agile thing, especially in extreme programming. Delay decisions until you know. So the more you can delay things in general. And so this works, you know, XP at the development level where you're, you know, trying to figure out what you're trying to do and delaying the decisions of what you might implement or how you might do things until you know better. So that longer you can delay certain decisions, the less mistakes you'll make. And he's doing this down here at the code level. So factories address this, and he uses all these words that are the buzzwords in object-oriented programming, cohesion, decoupling, testing. These are all great things. Design is flexible, split my problem into smaller, more manageable pieces. So a big key about Agile in general, which design patterns are leveraged often, is really maintaining or managing complexity. That's kind of what he's saying here. Everything is about techniques to manage complexity. TDD is a technique to let you manage design, testing, and implementation all in this method. So we're back to the question again. What are factories exactly? Well, factory is, and he says the same, anything that you use to instantiate other objects. It could be a method, static or not. It could be an object. Again, we hear the word factory and we want to think object, but often it's factory as in factory method, right? So he makes a mention. So in chapter 11, we talked about abstract factory, and the big key difference is abstract factory is not just one object, but a family of objects. And that's what makes, and again, this is one of the Gang of Four patterns here. There's a category, which he talks again down here before the creation patterns or the creational patterns. And those patterns for the original 24, abstract factory, builder, factory method. So these are the two things that call out factory in the book. Prototype and singleton, which we were supposed to cover next, but we covered before. And these are all things about creating objects, right? And then he goes back, and I believe they talked about earlier in the book. Three patterns are behavioral, structural, and he's calling it factory here, but canonically the name is creational. And so behavioral are used to contain variations on behavior, structural, about putting objects together. So he says, in integrating existing code into new object-oriented designs, it's really about how you fit things together. And the factory is creation of objects. So it after the fact, because design patterns, we're looking at patterns and seeing what patterns existed, and then, and if you read the original book, they say somewhere, nothing that's been less than 3 times if you pull into something. So it had to independently occur 3 times before it became a pattern. And so you can see in the patterns of patterns, these are the kinds of patterns, right? And so, for the Gang of Four, they had 5 specific patterns for consistent things that we realize we create patterns in these ways that are useful. So we have a context. We need to handle variation in new ways. And so when you're making new objects, you want to focus on, and I realize the sentence here that I cut off, how you want to use them. That's the behavior, because it's how they're working. When you want to incorporate objects into new patterns, I want to use the structural, right? So again, and so use of patterns is a natural result of hiding variation. I know in some of the other ones we're talking about, isn't this just what happens when you do good? If you SRP and you refactor, you kind of independently arrive to a lot of these patterns with, if you have a decent design sense. So we had studied this strategy pattern before, and the context object there, in this case, the sale order. Sale orders have different kinds of taxes. If I recall this one right, it was like, New York tax versus, American tax versus Canadian tax versus, I guess Nevada has no sales tax or whatever, If the sales order just uses a tax object, which, that design pattern allows me to switch out the different tax objects without knowing how they work. Well, he doesn't know what's using it. So who knows who gives them? Someone else. And again, single responsibility. I keep calling this out, where sales order only knows how to use tax objects. It doesn't know how to make them. And it shouldn't know how to make them, because then this makes it generic. So you have another object, someone else here who knows how to make it, and then you have different situations. So per that original example, if I remember correctly, it was different kinds of taxes. So you can imagine there's a Canadian factory, like actually a Canadian abstract factory that gives you both a sales order, which might have a slight difference, and a Canadian sales tax. And then you have another, like an American abstract factory, which gives you a, sales order, maybe a different kind of sales order, maybe the same kind, but an American tax object. And so those factories know what groups go together, and the sales orders don't have to know anything except that I get a tax object and I call it this way. So Al likes to call these universal context. He says the factory is the universal context he was talking about. So way back in chapter 13, when we were talking about the CAD CAM with the various model types, and we ended up going the bridge because we had to vary on 2 sides. We talked about a universal context for software development, which he says, hey, here's my rule. Consider what you need to have in your system before you concern yourself with how to create it. That is, we define our factories after we decide what our objects are. So the rule is decide what your objects are and how they work, then decide how to instantiate it. And again, complexity management. The thing is, we usually kind of jumble this together, and now you have two concerns to think about instead of one at a time. So he gives you this little thought experiment, which I think is actually a pretty good one. So you got a project, and there's many different cases, lots of variations, lots of ifs, lots of switches. And again, ifs and switches always beg, to me, polymorphism as the only solution. So if we could start before the code was written, this, whispers very strongly about TDD. What could you do if you didn't have the code to start with? Team lead says, okay, we're going to break into two groups. Group A will decide what the objects are and how they work together, i.e. primarily the actual business strategy. And group B will have the task of instantiating the correct objects under the right situation. So we split the task between how they work and how they should be grouped and created. So I think this part just says what I just said. Group A will design them according to the rules, but only how they work, right? So they don't have to worry about the different variations. And he wants to ensure that we do not worry this group about that, because group B does the stuff that will instantiate the right objects for the situation. So group B knows the cases, and group A knows how they work in general. So group A's code might have more than just instantiating, and there's another name that he has, a different kind of factory. Their factories might be managing factories, which do more than just instantiate. And again, depending on the situations, you can imagine they're very complex rules. I have this group for here, this group for here, and then with resources, you might have lifestyles. These live this long, and these need this, and this is renew, connection pools. There's actually connection pool, I believe, is next pattern we're coming up on soon. So that kind of hits that sort of managing thing. So factories can be quite complicated, or they can be super easy. It all depends. So who has the harder task? The one defining the objects and how to use them, or the one that knows what objects are needed? Most people, he says, thinks it's group B because they have straightforward rules. And again, they're decoupled from each other. So it's easy to implement the rules about when to create the objects. But he says, consider this. How much does the work of B simplify the work of group of A? And he'd like to say quite a bit, because they have a very narrow focus, right? The complex code is usually difficult to attend to the cases at hand. What objects do I need? That's the complexity. So group A only has to design interfaces and classes, right? And just the generalized behavior. Group B figures out which implementations and derivations go together. So both sides have an easier job. We split the creation and management objects. Again, complexity management. So things are simple. He's got this picture that basically says the client uses a creation object, aka factory method, whatever, to create the objects, and it just turns around and uses these objects. So I think to a lot of people, this picture is like, wow, what is he saying? Wow, this client uses a factory, gets some objects, and then he uses them, right? This is, especially as a beginning programmers or procedural, it's like, oh, why would you go to that indirection? Well, if you're writing a 10-line shell script, you're probably not. But if you have code that lives this pattern, that does in factually put in a new indirection, becomes much more useful, because this client now can be used in different situations, and you can change the factory. Because there's another object that basically runs this code, instantiates a client, instantiates a factory, and that'd be another abstract factory. That's why you'll see in a lot of Java code factories that use factories, and that's kind of like, oh, some other guy determines what client and the factory and gives this factory to the client, or maybe runs the factory and passes it to the client. So factories follow our guideline, which of course you want to increase cohesion, loosen coupling, and make testing better. These are all things that we cover. So the approach here is 2 steps. Define how they work together, and this is the thing he said earlier, write factories that make the right ones for the right situations. And again, I think without sufficient experience, which is either complexity or longevity or both, a lot of times this may seem like a lot of work that might not be worth it. So sometimes I think, at a certain level of experience, or design savvy. You go, why do I need this? Why can't I just put it all in the same place? And again, for short-lived small code, that's often perfectly adequate. All right. He's talking about, again, I think the thing he just talked about earlier. Step one isn't concerned about which objects get instantiated, and step two doesn't concern with how they work together. So SRP, we put them together. Objects should either make objects or use objects. And again, SRP, single responsibility principle. One set makes them, another set figures out how to use them. Right, and then of course he says this once again. This is the fifth time he said this. One makes, others use. But I think the good word is division of labor, clear division of labor. This is what allowed the Group A team and Group B teams to work independently. And I think we've come across a lot of situations where we can't split the work because we can't divide it in this kind of clean fashion. And a lot of times you can't split the work this way. But you can see that in our team. It would be great if I could say, hey, Andrew, you do this, and Brett, you do this. And then like Group A and Group B, and you meet in the middle, and then, link, 3 lines of code and all works. That's great when it happens. It doesn't happen that often. Sometimes it doesn't happen because we're not using big patterns, and other times it just doesn't happen because it's hard. This software is actually hard. Okay. So he's got this big picture that just confuses everything, because I take that. It doesn't excuse it. If you know what it means, it's like I think Andrew looks at this as, what is this saying to me? Just as as the for people who don't know, the most junior guy in the team, it's like, oh, why do I have these pictures? Well, the using object, of course, uses an object of this interface, which can have multiple implementing classes. So for me as a using object, I only know that I use objects of this abstract class, and they can be any number of subclasses with varying behavior, but they implement this interface. So all I know about this is I don't care where these guys come from. The other guy here, the factory object, he also he actually creates these objects, right? He knows what these are, but not how people use it. And these two are basically 22, 2 separate pictures. They have their own tiny little worlds, and then some other guy grabs the using object in the factories and puts them together. So, and that's pretty much what these say here. And again, separation of concerns strengthens cohesion, i.e. the cohesion, this first thing is I'm only focused on the use, and the cohesion of the second one is I'm only focused on what do I create when, and then you can see they're decoupled. Neither of these need to know anything about the other guy, except for this interface structure. They both deal with the interface structure and nothing else. And then, so now we have more opportunities for encapsulation, which says value this, and again, what I said, implementation class hidden from using object. And the beauty here is you can add new implementations or take one away without changing objects. So back to this picture, I can do derived class C. This is a new class, and I don't have to change as long as I don't need to change the interface. And sometimes you need to change the interface. If I don't have to change the interface, I can make a C or a D or an E, and using object never changes, which is open close rule, which he'll also mention later. And right, so that's great. And again, the groupings of those, if it has to change over here, the factory can change there. So he says this improves tests because using objects should test in the same behavior. I don't have to test everything. So a lot of times, yeah, I think that's more Liskov substitution principle, where I can replace any subclass with the parent and they should all work the same, which bears some measure, but tests. And actually, in our spec, we have that example should act like, and you use a shared example. That's kind of actually implementing this in reality. Well, for polymorphism and doing the right things, we can say we can test a whole set of new classes by running the same kinds of tests on the new class, which we use in our code. I don't know if the DCT does that, but definitely a lot of the mainstream code, we definitely have a good use of that. I want to say it's probably mostly Diego putting those codes in. Okay, so limiting the vectors of change. It sounds so dramatic. Major issue really is we want future maintenance easier and more economical. Right? This is always valuable for code that lives, especially, you know, we want to use OO techniques to avoid cut and paste and optimize reuse. And, you know, Andrew's kind of trying to do a little bit for this on, I won't mention the project, but the thing that he's got things, right? And he should be going, oh, yes, I'm going to reuse stuff, and that's good. And here we go. He mentions open close principle again, which he doesn't define it here, but redefined here. What is it? Open close. New code is open to, what's the word exactly? It's open. You can change, you can add new stuff, but it's closed to modification, i.e. I don't have to change. I can add new behavior. I'm going to paraphrase it because I don't remember the exact phrasing is. I can extend behavior, i.e. open it, but I'm closed to modification. I don't have to change the other guys to do it. So that first picture back up here again is this using object hopefully doesn't have to change. I can simply derive a new thing. I've designed it in a way that I derive a C, and now I have new behavior. I never had to change using object, right? And that's a powerful thing. If anyone had to change and you had to start changing like things on 3 classes, you go, oh, that's really terrible. Wouldn't it be nice if I could just derive a new class and then, you know, make a new factory to swap that in? Okay, so open close, yes. I'm adding new code rather than changing. So he said what I just said, reduce cost of maintenance, which I just said. So factories, often many users, one factory. Okay, yes. So you have many users, one factory to build. And so here we can limit if creation's in one place, code modification there. Again, less work, where change is the highest cost. You know, when you change, then change object required, you got to change stuff. And again, there's a, if and when we hit refactoring, there's a pattern called, or a smell called shotgun surgery, where I make one change, I just shotgun, because I have to hit like 12 classes, and that's a bad thing. I make one change 12 classes, that's a smell. There's a pattern to fix that, which might actually be a design pattern implementation, but certainly it's a structure. Factories limit the maintenance to the user of the object or the builder of the object. So modify both less. Again, I kind of like this wording. I can worry about instantiation later, which, and again, managing complexity enables you to focus on the pluggable aspects of design, right? So again, it's a concrete action to take things out of my head. I'm not going to worry about building this. I'm going to worry on the problem and how to best do that one. And later, I will worry about that one. So this makes integration easier. I think I already spoke to, but let's see what Al says you're saying on this one. It's more expensive to integrate new code in a system and is developed in the first place very often, right? You can say, we all want that fresh project that we can write from scratch without constraint. Integration is always hard. Separating use from construction makes this lower because you only have to deal with a new case, because you already have a framework for adding new case. So if you already have a structure to use factories or abstract factories, then you don't have to make a new one. So going back to the original picture, so I can make the C class, and then I can go back and tweak a factory to add C where appropriate. He talks about this complex code. Okay, and again, it's because this seemingly non-intuitive thing is because we're doing things the OO way, as opposed to procedural, which is mostly complexity managed using objects and classes. So instead of using a switch to vary behavior, we vary the objects. And again, this is, I mentioned earlier, I see ifs and switches as sign we need polymorphism from the OO perspective. And factories is just part of this, makes it easier. So what do factories do? Do they do more than just push objects? So we'll go back to some of our previous pages, analysis matrix. We talked about using abstract factory, which allowed sales order to deal with only the concept of taxes and freight charges. And then we made new things by making the new cases updated factory. So retrospective, exactly, we use a case where a sales order, this could change and taxes can change. And we've made new tax types, and then we've used a factory. So this is how you do that. Factories can also manage objects, sometimes want to share, sometimes want a limited thing, database connection here, so like connection pools. Factories can be concerned about which objects and how they manage. So he talked earlier about managing factories, which may include how many objects are instantiated, how they're shared. This allows us to put all the rules there. So anytime that you've had to look here, where am I creating, where am I using, where am I creating stuff, and you can see it gets spread out. You're consolidating things. So you can imagine a long leg system with like resources, like for example, like passenger. Passenger spins up workers and it kills them when they're idle. And this allows passenger to keep a low memory. So it has basically the concept of like object life cycle. I'll leave it in place and I'll kill it either when it's been idle or it's too big, you know. And you can see, oh, these are kind of things that could be factorized where I have not only what do I make, but how do I let them live, or how do I get access? Someone asked me for these workers. They don't know that I just killed it or not, and they shouldn't know. Blah, blah, blah. So this is, I think, a legit thing. Some people say factories are solving a problem that pattern are created, i.e., because you've added these layers of indirection that arguably make more maintainable objects. Now you need these other patterns to make things that we use, when in the old days we just put it all in one big 100-line function, you know, which, you know, me saying it that way intentionally sort of explains a little bit of the, well, when you hit the 100-line function, you start getting angry. It can be a burden to client. I guess the 100-line code I'm talking about forces you to know about these objects and complicate the code. So it is true. Fact is, indirection puts complexity, and sometimes you have a lot of indirection, which can introduce its own kind of complexity. But the point here is factories hide the fact that extra objects or different objects or objects behind the scene are there by abstracting in a way. So I think it comes down to really complicated problems are always complicated, but you can make them easier. All right, field notes, comic problems in making objects. You know, if you try to follow the guidelines here, you'll see there are recurring problems happening in different situations. Can you say creational patterns? Yes. You know, so there are particular solutions, aka how Daniel 4 came up and their design patterns. Talked about abstract factory before. We're going to talk about a couple more in the following chapters. And you know, singleton we did. You know, singleton is the factory that gives you the single object. So again, this is creational because I'm getting an object. It is a kind of factory that ensures there's only one kind. And, you know, those are useful for those things. So here's some other examples here. Complex and creational. He's created factories using the bridge pattern. Right, we did that one. Complicated pattern, other things that use decorator. He's got other ones. He's done chain of responsibility, which is not going to talk about the book. And so you can see different ways to do these things, etc. So let's summarize. Why should factories make our life easier? Because they encapsulate the rules under which we have the circumstance, which objects we have under which circumstances. So this allows the rest of the system to use the object without knowing. So single responsibility principle makes our life easy. So let us do some review questions. Actually, any questions before we do the questions? Questions or comments before we move forward? Now everyone's muted, so if anyone's talking, I have no idea. And no one has video, so I don't know if you're talking and I need to read lips. All right. Oh, I did not realize there are Snapchat-like filters on Hangouts, because you know that makes the focus on design patterns extra clear to focus on those things. Okay, so all right, so one more thing. So I'm just going to round robin. Diego, define a factory.
All right, factory is responsible for creating an object and ensuring the object are ready to be used.
Yeah. So what kind of things can be factories?
What kind of things you can factor?
No. What kind of implement? How can you implement factories? Like how does it? Oh, I was going here to sentence that it could be a method, static or not. It could be an object.
Oh, well,
That's kind of what I was saying. People always think there's only one way. No, it could be a method, aka factory method.
yeah, you can, of course.
It could be a static method. It could be a factory.new.instantiate versus, a class dot whatever.
I also, well, I'll quite often use hashes.
Mm-hmm.
So pretty much like a key will give me the the value of a specific key is the object that I'm looking for.
Yeah.
Whenever I don't need to pass any value to it, right? So I get there will be a factory of classes, and then you can do like a my factory hash, and you pass the key of the type of object I'm talking about, and get the right class that creates that.
Yeah. Cool.
So I do that a lot, and I showed that to Andrew a couple of weeks ago.
All right, cool. Name one factory chapter used in a previous chapter.
Oh, by the way, one thing about the implementation, you can pass as part of the key also a regular expression.
Oh yeah.
So you can define the key as a regular expression. So anything that matches a regular expression will also return the correct object.
All right, Andrew, name one factory pattern that was used in a previous chapter.
Just that one. It was, oh my gosh, let me just look at the package. It was the one we just did. What's that one? Oh my gosh. The singleton?
Yes.
All right, that's actually a future pattern, but we did it in a different order, so I'll let that go. But yes,
yeah.
Abstract factory was the one that was mentioned in the book for previous, where the sales, the one that we just mentioned several times, but at least here, analysis matrix, he mentioned sales order, way up here, sales talks. I talked in great extent about abstract factory on that one, somewhere up here, abstract factory, yeah, chapter 11, abstract factory. So he also mentioned, for your next question, he also mentioned, what did he mention? Factory method. Yeah, we think about a lot of stuff here. Factories, roles of factories. Yeah, he does 16, 17. So this section here, decorator. He also brought them up in the bridge. There's context here, the bridge, decorator. All right, Brett, when it comes to managing object creation, what is the good universal rule that he emphasized 3 times in the chapter?
I have not been paying attention that much. I apologize.
All right, the good rule is to split what objects.
Actually, a better rule is
when to use
pay
versus
attention.
who to create. What?
A better rule is to pay attention.
Good rule too. Yes, to separate the create. It was the group A, group B. How they worked, how they are used, and what they work with, and who creates them. Single responsibility principle. The thing I probably said probably 27 times. All right, interpretation. Developers who are new to OO programming often lock the management of object creation, object instantiation. What's wrong with this? Don.
Let's see. I forgot exactly what he said. But just that you might, maybe because you might need a different object at a different time, you want to separate the logic. It's kind of the whole thing with factories. You don't know exactly the context you'll be using it.
Yeah, I mean, several things. One is complexity. Now we've mingled 2 concerns. The word he called out is sometimes you do the wrong implementation pattern because you decide too early. Oh, this is how I need to make objects, so this is how I'm going to make them. And then 3 uses later, you go, oh, that was not really a good way to do it. But if we delegate that to a factory, then one, we indefinitely delay the decision. But now we use factories. We don't, like, we can have a really complicated thing. We can handle all the cases, right? Once we use a factory and everybody uses the factory, then using classes all become real easy. I get some stuff and I use them. I don't figure, oh, it's a situation in A, I can do this, a situation B, I have to do that. That's all able to be handled by the fact that we use factories. All right. Factories increase cohesion. What is the reason for this? Scott.
Oh. Factories increase cohesion because they group together the problems involved with creating and organizing objects together.
Right. Right.
So,
Right. So the cohesion, the factory is only focused on object creation, and therefore it's very cohesive. If it's also dealing with other concerns, it's not cohesive. All right.
Which means that if you lump the management and the creation, you decrease cohesion.
Yes. All right. Question. Interpretation 3. Factories also help in testing. In what ways is this also? In what ways is this true?
Ooh, can I do it?
Oh, actually, if Andrew wants to answer, you can jump in.
All right. I want to just present the opposite of the factory, which could be like a complicated case or if-else. And so instead of having this weird, like, all right, now I have to put in this condition to get this case, instead you can just test the objects that are being returned by the factory. And that way you just have a simple set of tests for the factory and its objects, and then a test or a set of tests for whatever is using the factory, instead of trying to create like a giant web of tests that you're trying to manage because you don't have a factory.
Mm-hmm. All right, that was good. All right, opinion and application. Factories are useful for more than just deciding which object to use. They also help with encapsulating design by solving a problem created by patterns. Evaluate this argument. So that was the thing I just talked about. Right. Where is that? That was right. Is it farther right? I'm surprised. I didn't think about it. That just changed. I didn't think it was this far. I know I even highlighted it, but I don't know why I can't see it. Oh yes, here you go. You might say factories created solved a problem that they created. So they also help us solve encapsulating design by solving a problem created by patterns. Evaluate this argument. I kind of sort of said what I said. Anyone have a this free option? Anyone have an opinion on this? All right, so I will go along with yes. Sometimes you start using patterns, you kind of have to start using factories, otherwise it gets unmanageable. So you have pulled in some complexity, but for a certain value. For the situations that factories is useful for, this is good. I imagine Diego, possibly Don, maybe even Brett may have seen back in the early heyday of J2EE, someone went and wrote a J2EE Hello World program, and so it was like 4 factories and 12 classes and whatever. And so when people are complaining about, oh, you design pattern crap, that's the worst of it. Because there's literally get the factory to get this factory, get the factory this, take the factory, get the object, instantiate the new object dot, blah, 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 boom, 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 hello world. And
By the way, I looked it up. It's called Hello World Enterprise Edition.
right. And so that's the example of the words, the design pattern, where it's like, oh, for hello world, that's overkill. For the hard problems that J2EE was designed to solve, that's not bad to incur given the thing it's solving, but it's clearly like way overkill for hello world, and that's a little bit poker fun, but that's, you know, J2E was bloated and no one uses it anymore. So all right, so okay, so that being said, so if you got a 10-line shell script, don't use J2EE. I mean, don't use a factory. Does that make sense? Right? When your code's small enough, there is complexity. It definitely makes things, patterns will make things more complicated if you don't need it. All right, so that's where we are. I think that's all the questions.
I have a question.
Yeah, go ahead.
If using the factory, is there a way, let's say I'm creating a factory and I have several objects that this factory is responsible for. Do I do anything besides an if-else statement to create those objects or to use those objects within the factory? Like if this condition, return this object, else if this condition, etc., and then else, return this object. Is there a better way of doing that?
Well, so the thing that happens is, for example, when you use polymorphism to get rid of ifs and switches, it's really about taking the 20 switches and moving them to one place. So it used to be you have this code, if here, if here, if here, if here. Now you just pass an object that knows what to do, but at one level up, you have a, if this situation, use this object that does all those other things, right? So the right place for the if is in the factory, if the factory needs to handle several situations. So instead of it being sprinkled in your client code and sometimes in multiple places, it's all, so the thing is the if doesn't go away, but it gets refactored into one place, which again, when it's time to change, you go to the factory change instead of the 16 places that's littered in your original code. And you can probably now think back in code, oh yeah, I have these 6 ifs. I move them up one level and spit an object that didn't have to do the ifs. Then, I have one if at a higher level instead of 3 ifs at a lower level. Okay, any other questions? Questions, comments? Who's putting the factories in their shell scripts now? No, you're not supposed to put them in your shell scripts.
I thought you said scripts in general. No, I don't make shell scripts at all.
Yes, but I'm just saying your short ones. Hey, your short little things, don't put factories in them. It's just a waste of energy. But though technically it's a factory. If you moved all your creation to one method, that's technically according to the definition of method. So if you moved all your creation all to one place, that's okay. But if you had a factory that gets you the factory that you instantiated and you ran the factory method, which again, that's probably, if I got it right, pretty much how that Hello World Design Patterns Edition works. You had a factory which got you the factory you're going to use, instantiate the factory and call the factory method so that you can get the object that does the hello world. That's, insane for that, unless you just want to show how stupid you can be. Okay, well then, Brett ended up doing 21 before, so let us pick the pattern after this one, which was, which one? Object pool. Object pool is 1, 2, 3, 4, 6, 7, 8. All right, let's just do object pool. We can keep them short. Short is better than long. Who wants object pool?
Going once.
Going one.
Going twice.
I'll
do it.
Oh, Diego will do it. And the world will be better. All right, Diego will do this. We'll see you in 2 weeks. Thanks for joining Nested Loops. I find it interesting we have the SpongeBob Pirate as a filter. We should probably avoid that during lecture talk because it doesn't really help us focus. Okay, enjoy and play with your filters. Thank you.
Thank you.